More than 250 experts in the traffic signals industry joined together in person to hear a range of papers here in Nottingham. These recordings are brought to you by AGD Systems, Colas, SRL Traffic Systems, Smart Video and Sensing, Vivacity and Yunex Traffic.
Hello everyone. Hello. Today I'll be presenting about our new SPaT algorithm that we specially developed for this project Synergy that we completed in Munster. Me and my colleagues actually finished the site assessment report and test in last May, so it's very fresh. I should be giving you a very quick overview about the project. I'm going through our scope and present the new features that our algorithm presents. So, location, this Connect Mobility project is what a partnership between us and Transport for Greater Manchester. This project was also funded by Innovate UK, where they are aiming to complete autonomous vehicles and connect mobility trials around airport area, Munster Airport area. And as you can see, it was a very challenging site because we had 5 stages, 10 traffic phases, and 14 lanes approaching the junction. So it was a very particular site to work on. As you can see in here, we installed and configured our ESCOS RCU that you can also can see in our stand, is available. We also did the installation and configuration of V2X outstation into the existing controller. During our site assessment test in May this year, we have the chance to actually validate our new SPaT and map and Ivi Messages services. And as you can see in here, we have the results of the coverage of our services in all of the approaches of the junction. About our scope, we started with the map, the creation and elaboration of the map, Map2X. We used our internal Map2X tool to create this map. As you can see, we can create lanes, ingress and egress lanes. We can adjust speed and lane width based on each site. We can also create divergent merging points, and because we have the satellite view, we have a very accurate map, so we can actually make sure that all the geographic locations of the map is correct. We can bring signal groups and phases to the map as well, into the tool, so you can actually make sure that all the geographical and topographical parameters are included in the map. And I think that the most important thing are the outcomes of this creation. Once we finish the map, we can export 2 files. One is the KML file, as you can see, where you can use our Google Earth applications to verify visually if the map that we created is actually geographically correctly in the location. And the most important one is the XML file, which actually will be converted, is converted from XER extension to XML file, and then you can actually upload into the V2X outstation. Other part of our scope was the Ivi Messages. For this project specifically, we deliver 4 types of Ivi Messages, the traffic signals ones, and as you can see, once the OBU approaches the vicinity of the map area, you can actually receive the traffic signals into the HMI, which is a human-machine interface. We can also get the speed limit, but in this case, is in kilometers per hour. So that's the difference between the 50 miles per hour and 72 kilometers per hour. And as you can see on this top right picture, we have the road speed limit sign showing on the HMI and also our current speed. We can also create and customize icons and messages to the dual line, in this case the dual line VMS, but you can also create multi-lanes. And very specific for this project, we also provide this airport sign, so it's low aircraft zone, As you can see, very sorry for the pictures. This SAT was completed during the COVID, so we didn't have much resources available in the car. But if you see in the top here, the HMI, you can see a very tiny little sign. And this shows the airport, the low aircraft zone. In here, I'm going to share with you bits of this video that explain our site acceptance test. And as you can see, we were recording on a Teams call and we were extracting data. And so it was very tricky during COVID stuff because it was in last May. But as you can see in there, all the Ivi messages that I mentioned before are displayed in the HMI. So once you approach the map area, you'll be able to see the display being changed. As you can see there. Wasn't part of our scope, but we tested and validated during this SAT as well, our glosa. So as you can see in the first picture in here, we, based on your speed, the current speed, you can actually receive the advisory speed to be able to achieve the truck signal in the junction on time or for green. And you can see here as well, depends of the lane that you are, everything came from the map 2x that we created. For our new SPaT, this is a flexible and much efficient with new features that we specifically developed for this project. One of the main things I would say is the second one here, the control mode dependent. It's flexible with any stage and phase arrangements, so we can have green signals and green arrows. We can have unlimited stages. And the controlling mode independent, I think, is the main one, is the fact that we don't really need to work on fixed mode, because we are very attached for that. Time to red and time to green. The way that this algorithm works is basically the algorithm reads how the controller is working for 5 consecutive cycles. And then he understands that as being something like a kind of fixed mode. And based on that, he can predict, and actually now is much improved because the prediction is only 2 seconds for time to red and time to green. Faster configuration, because you don't need to spend much time doing manual inputs and typing and actually spending our time to do the V2X outstation configuration, because of this algorithm is much faster. We can configure and finish the process, the initial process, much faster. Time confidence levels, as I mentioned before, if after watching the controller mode for 5 consecutive cycles, this can actually show us and display what is the confidence of that prediction. And I think one of the main outputs for this project is the opportunity to be connected to the AWS. So we can collect the data, we can analyze the data, and also keep working ourselves and our teams to try to improve our services. So I was very quickly. My colleague Jack Durdo is the PL and product manager for this Connect Mobility scope. But if you have any questions, any further questions as well after this presentation, we have some colleagues around our stand, so then you can actually come to us and ask any question. But at the moment, thanks for joining me, and I'd like to know if you have any questions.
Thank you, Anna. Really good, and also quite impressed by the confidence intervals that you've managed to get with the glosa timings. That seems really good. So if I could start with a question. Mm-hmm. What's your view, if once this becomes used and drivers have access to this and can see this and start to change their way that they're driving, maybe slowing down, particularly if they're not going to get a green, but drivers further back might have got green and might be impacted. there's potentially a feedback loop going on between the signals and the drivers and changing the response of both. Is that something you've considered at this stage or are looking at for the future?
I think our team is working on that as well. But with these, I think that the old Polo already had these inbuilt on the onboard units and actually be able to receive that. But as far as I understood, is still blocked, it's not available yet. But we are working internally with some of other resources to trying to get these into Apple Play and Apple Car, actually, in Android Auto. So then these would be available for much more users than just the ones who has cars, which has these OBUs included. So we are thinking about these as well.
Okay, thank you. Are there any other questions? Oh, I think, is that Tony up there?
Hello.
Hello.
Just asking necessarily how you think this is going to go forward for interaction with other existing technologies, and I'm thinking, obviously, following on for yesterday's group, Mover, how this is going to interface with Mover, because Mover will change its timings frequently from cycle to cycle. Will we indeed have any interface between Glosser and associated technologies and Mover?
I know that we and our colleagues from Germany is actually working on a trial to integrate with Mover, because we're thinking about this as well. For this algorithm now, we have this flexibility of we just need to analyze 5 cycles to actually the SPaT. I understand that this is a kind of fixed mode, but I know that we are developing and studying how can we integrate that with Mover. And as part of these tests as well, as you can see on the video, we used a third-party OBU. So we're trying to get these flexible and open to others companies as well. It's not only a Siemens OBU.
Another question over here, please.
Simon Notley from DINIC. In interest of full disclosure, we have a topic on a presentation on a very similar topic, competing technology, later on. So answer as you feel fit. What are your thoughts on two challenges with Glosser? Number one is similar to Mover. What about demand-dependent stages? And what are your thoughts on how to deal with those? Because they could happen or not. They're completely binary. And similarly, queues. So I saw in the video there that the driver changed lane in order to continue driving, when if they'd continued driving forwards at the recommended Glosser speed, they'd have run into a truck, because the Glosser is to the stop line, presumably not to the back of the queue. So do you have thoughts on how to meet those two challenges?
Yes. So for our first question, I think I will talk to you later after this presentation, because I need to make sure that my colleagues actually is agreeing with my view. But yes, about the traffic that you cannot predictive. That's why I think that if you get the chance to have these available on Apple Car and Android Auto, you actually make these chance available for much more users. So then you can try to predict and make these even more accurate. But I think that all of these Glosser and Connect Mobility is very fresh, is everything very new. We are working as much as we can in many of all the projects trying to develop new and flexible and smart solutions. But as you can see, everything is still the start. So I think that if you can just join our knowledge and trying to get a better solution would be the best way.
Any other questions from the audience? So I've got one more, just touching on that then. So you're saying about Apple Car and Android. Do we need to actually get to a kind of critical mass of users and sites before it really becomes useful? So is this the sort of thing where early adopters will get very little out of it, but as we get to a point, and if so, what point of deployment and number of people using it will we really start to see people sort of taking it on and actually making real good use of it?
Well, everything is a trial yet, but I know that we have a lot of colleagues in UK and also in Germany trying to get the answers for that. But yes, I honestly don't know how to reply that yet, but we are studying and doing our best effort to get the answers.
Okay, well, thank you very much.
Thank you.